Hi, Sunil.
Hello, sir.
We'll wait for another 5-10 minutes for others to join the session, then we'll start the session. All right?
Yes.
While we're waiting for others to join, if anybody has any doubts regarding previous week's sessions or lectures, then we can discuss those. You can raise your hands. Then I'll allow your mic and you can unmute yourself and ask the questions. Also, the last week's session, we had missed the last week's session due to some medical emergency on my part. I'll try and request the NPTEL people to allow us to have another session in the coming week, probably on Monday evening. And if that is allowed, then you'll be provided a mail with the link to join the meeting, and we can have another session to compensate for the missed one last week. All right. Can somebody raise their hand and confirm if my slides are visible and changing? I've allowed all your mics. Can somebody confirm if my slides are visible and they're changing as well? Yes? Yes, Rachna, you can unmute yourself and speak. Yeah,
Sir, am I
yeah,
audible?
you're audible now. Yes.
Sir, actually, I have one query.
Yes.
I'm preparing for the exam, but most of the content are not. Actually, I didn't get the point. What is it? जैसे actually threshold है, तो वो कभी क्लोराइड डिफ्यूजन कोएफिशिएंट है, वो कहाँ पर हो रहा है, कभी कम हो रहा है, कभी ज्यादा हो रहा है. Then for the exam preparation, जैसे मैं असाइनमेंट सॉल्व करती हूँ, तो then these are मैं इंटर रिलेट नहीं कर पाती हूँ जो लाइव वीडियोस चलते हैं उसको असाइनमेंट से. Then will
Okay.
you please suggest how we will prepare for the examination? In which point we have to concentrate? किस तरह से concentration करना चाहिए? Then it will be helpful for the examination.
Uh, okay. Can we discuss whatever doubts you might be having? Can we discuss them at the end of this session? Will that be
Yes.
fine?
Okay. Actually, I don't have doubts, but I cannot correlate the audios or videos which I listened in the NPTEL, and I can't. Most of
Correlate.
the
Correlate मतलब
नहीं.
क्या दिक्कत हो रही है आपको?
जैसे मैंने अभी वीक 12 का सर सुना, तो जो एकदम लास्ट सर का जो सेशन था
हाँ हाँ.
कि लास्टली वो कंक्लूड कर रहे हैं कि वो ये नहीं हो पाता है कि हम नहीं डिसाइड कर पाते हैं कि क्लोराइड थ्रेशोल्ड और ये क्लोराइड डिफ्यूजन कोएफिशिएंट के प्रैक्टिकल अभी जो चल रहा है उस पर नहीं हो पाएगा बोले कि हम अभी नहीं बता सकते हैं कि इस पर अभी और रिसर्च होगी. हम एकदम पॉइंट टू पॉइंट नहीं बता सकते
हाँ
कि
नहीं,
क्लोराइड.
वो तो ठीक है. वो तो रिसर्च की बात तो अलग है. वो तो रिसर्च
हाँ,
तो हमेशा एक
अभी तक
कंटिन्यू होता रहेगा. बाकी आपको जो भी
हाँ
कोर्स में पढ़ाया जा रहा है
बस.
उसी के रिलेटेड ही क्वेश्चंस आएंगे.
हाँ, पर सर जैसे मैंने अभी असाइनमेंट भी अटेम्प्ट की थी,
जी जी.
तो जैसे मैंने क्वेश्चंस पढ़ी और उनको सॉल्व करने की कोशिश की, तो जैसे 3 आंसर थे उस क्वेश्चन के, तो मैं 2 करेक्ट दे पाई
तो
और तीसरा नहीं दे पाई. तो फिर मैंने उसको कोरिलेट करके देखा वीडियो से, तो मैं थर्ड वाला कोरिलेट नहीं कर पाई. आई विल रेड इट फॉर यू फॉर द वीक 12 असाइनमेंट. आई हैव जस्ट सॉल्व्ड इट.
no, actually, today we'll not be discussing the week 12 assignment. After the
ओके
deadline is over, we'll be discussing that in the coming weeks.
ओके सर, एक्चुअली मैंने अभी वही पढ़ा था. तो जैसे मेरा जो क्वेश्चन था वो फोर्थ क्वेश्चन था, क्लोराइड थ्रेशोल्ड वैल्यू रिपोर्टेड इन द लिटरेचर. तो
Mm-hmm.
कंपैरेटिव वैलिडिटी थी, लेकिन वो मैं आंसर नहीं दे पाई. तो ऐसा
Okay.
हुआ कि वो मुझे ऑप्ट करना पड़ा.
ओके. उसका डेडलाइन आ गया है? उस वीक का सबमिशन का डेडलाइन हो चुका है?
हाँ सर, इसमें डेडलाइन गिवन है, दैट्स व्हाई आई जस्ट सबमिटेड इट.
नहीं,
19
व्हेन इज
अप्रैल
द डेडलाइन? ओके. आफ्टर तो फिर हम 19 अप्रैल के बाद ही उसको डिस्कस करेंगे. ओके. ठीक है. आप आपको जो
May
भी.
I state something related to this question?
यस डॉक्टर सतीश, यू वांट
Yes,
टू
sir.
स्पीक समथिंग?
Yeah, this matter also about this question number 4. You
योर
know, the
योर
last lecture,
वॉइस इज ब्रेकिंग.
maybe it's a connectivity problem.
ओके.
This last lecture covers that aspect. Question number 4 is very covered by the American professor. Then just listen to lecture number, last lecture. He has covered this particular question.
ओके. थैंक यू.
Uh, that- it
डॉक्टर
is the
सतीश, योर
last.
वॉइस इज ब्रेकिंग, so we are not able to listen to you
Okay.
properly. Yeah. Okay, thank you. Anyway, Rachna, you can whatever questions are given to you in the assignments, those are purely based on what has been taught in the lectures. So you can, if you're not able to grasp onto some concept that has been taught in the lecture, you can rewatch those lecture, and if you have any specific doubts, then we can discuss it in the sessions, or you can ask them, or you can post your questions online as well in the Swayam portal. But you'll have to solve the assignment questions yourself. We'll be discussing the assignment questions only after the deadline of submission is over. All right. And for today, I'll start this session. And if you have any doubts regarding this course, then please wait till the end of the session. We'll take all the doubts that you might be having so that uh, it will be clear. Okay. All right. Okay. Hello everyone. Welcome to the weekly discussion and doubt clearing session number 9 of the NPTEL course Maintenance and Repair of Concrete Structures NOC23-CE06, which is taken by Professor Radhakrishna G. Pillai of IIT Madras. I am Ashirvad Satpathy. I am a PMRF research scholar at IIT Delhi, and I'm also the officially assigned teaching assistant for this NPTEL course. And what I do is I take this weekly sessions where we discuss the previous week's assignment problems and how to answer them, how to tackle those problems. And also we take some of your doubts that you might be having regarding the lectures of the previous weeks. There is another officially assigned TA to this course. His name is Umesh. He takes his sessions, weekly sessions on Fridays from 7 to 9 p.m. And I usually take my weekly sessions on Saturdays from 6 to 8 p.m. Regarding the previous week's weekly sessions, I have posted the link of the YouTube video of the last week's weekly session number 8 in the meeting chat. You can check it out if you have missed that session. I've also posted what I do is I usually record these sessions and post it on YouTube, and I have shared the link of that as well. And I also use this, whatever slides I use to teach these sessions, I also upload it on a OneDrive folder. So I have also shared the link of that folder in the meeting chat. You can always check it out. That link will remain same for the duration of this course. Okay. In today's session, we'll be discussing the week 8 assignment 8 problems. There are around 8 problems, and these problems are related to the waterproofing courses or various polymeric coatings that we apply on the concrete surfaces to resist water from getting inside the concrete structures. And these 8 problems will be regarding more or less regarding those waterproofing coatings and membranes. And at the end of the session, we'll be taking some of the doubts that you might be having related to week 8 lectures or any of the previous lectures, right? So the first question of this assignment 8 was, as per the lecture, alkyd coatings can be recommended to protect the exposed concrete surfaces in a coastal environment. Is it a true or a false statement? Can somebody answer to this question? I've allowed your mics. Let's keep this this session interactive. So that we'll both benefit from the session. You can raise your hands and answer to the question. Yes, Dr. Satish, you have raised your hand. Go ahead.
I think Madam will also raise the hand later.
I guess,
Nobody,
Rachana, do
I
you
will.
want to answer this question?
Which one, sir?
The first question that I just read out. Can you see my screen, Rachana?
Acidic coatings can be recommended to protect the exposed concrete surfaces in coastal region. True, sir, true. Alkyd coatings can be recommended as per the lecture because some questions sir आते हैं but कुछ questions नहीं होते हैं related.
No, I differ. Answer is false. In the lecture, they told that this type of coating is meant for steel and timber and not for. So statement answer is false.
Yes, thank you. Thank you, Dr. Satish. Yes, actually, this is a false statement. If you have watched the lectures carefully, alkyd coatings are not recommended to be applied on concrete surfaces. Rather, these type of coatings are used to protect the metallic components like steel or any other metal components or even on timber surfaces. And so this was in fact specifically mentioned in the lecture that in any kind of concrete surfaces, these kind of coatings should not be used. So this is a false statement. Alkyd coatings are not to be used on concrete surfaces. All right. Moving on to the second question. It was decided to coat the interior surface of the chimney of a newly constructed nuclear power plant. It's a nuclear power plant, and the chimney, the interior surface of the chimney is to be coated. Which among the following should be the two primary features of a good coating material for this case? And these are some of the features that have been listed out: high vapor permeability, high dynamic crack bridging capability, low resistance against temperature, good resistance against possible contaminants. Which of these features, two features you have to select, which of these features will you be selecting for such a case? Coating the inner surface of a chimney in a nuclear power plant. Yes? Can somebody?
High dynamic crack bridging capability and good resistance against possible contaminants.
Okay, and would you also try to answer, Sunil, why would you choose these two properties and not the other ones?
Actually, I am not familiar to this question. Actually, it is the 8 week assignment, and now it is running 11, 12. So I am not remembering exactly the
Okay,
theory behind this. Yeah,
okay, okay.
that's the
As
issue.
per lecture, high dynamic crack bridging capability,
Mhm.
but after checking there is a good resistance. I check it out. I only click the second one.
Okay, actually, okay, thank you for answering. Both these answers are correct. High dynamic crack bridging capability and good resistance against possible contaminants. First of all, high vapor permeability, it is not to be considered because anyway we don't want uh, the vapors or the water vapors or any kind of other vapors on any gaseous substances to get inside the concrete, and therefore the primary one of the primary requirements of coating is to prevent the ingress of these vapors into the concrete, and therefore it should not be permeable to high to vapors. So this is a wrong statement. Second is high dynamic crack bridging capability. So since this is a industrial structure chimney, and it might be exposed to vibrations, and therefore uh, this there is a possibility of formation of cracks due to dynamic forces, uh, since chimney is a stack like structure and it is a very um, high rise structure. Therefore it is also subjected to wind loads at a very I mean, at a greater height, it is subjected to a large amount of wind loads, and therefore there is a lot of dynamic forces that will be acting on this stack-like structure, which is a chimney, and therefore, due to the application of these dynamic forces, there is a possibility of formation of cracks. So, whatever coating that we are applying on the chimney surface, if it doesn't have a good crack bridging capability, then it will be also susceptible for to breaking due to or tearing due to the formation of cracks, and it will again defeat the purpose of applying the coating, because once there is a crack on this coating, then it will allow the ingress of water or vapors or any kind of other substances that we don't want inside the concrete. So therefore, the coating needs to have a high dynamic crack bridging ability. So this is the right answer. Third is low resistance against temperature. Again, we don't want that, because as it is a chimney structure in a nuclear power plant, of course it will be exposed to very high temperatures. Uh, very high heat will be evolved, and therefore the hot gases will be going out of uh, the nuclear power plant through this chimney only, and therefore it should have a good resistance against temperature variations. It should have a high heat resistance and not a low resistance. So this is a wrong statement. And the fourth is a good resistance against possible contaminants. Again, this is a true statement, because since it is a nuclear power plant, so it will be a lot of sophisticated chemical reactions will be taking place inside the nuclear power plant, and those will release fumes of hazardous gases or substances, and these fumes will contain airborne contaminants or airborne chemicals which might attack the concrete structure. And the coating that we are applying in the interior surface of the chimney, that should prevent from the ingress of these contaminants, airborne chemicals inside the concrete, and therefore it should have a good resistance against the possible contaminants. So these two statements are the correct answers: high dynamic crack bridging ability to sustain against the uh, large dynamic loads or the wind loads or any other, like let's say if there is an earthquake, and this is a very high-rise structure, then it will be subjected to a large amount of uh, loads at the bases as well, which might lead to cracking. So these dynamic loads can cause cracking, and the coating should have a good resistance against to bridge the bridge these cracks arising out of the dynamic loads, and then it should have a good resistance against the possible ingress of the contaminants that are airborne, or that are being released as fuels. All right. Okay. Moving on to the third question. Applying polyurea coatings over concrete pipes are sensitive to dash and dash. And these are some of the properties listed regarding the polyurea coatings: pot life, mixing ratio, relative humidity, atmospheric temperature. Can somebody answer to this question? You
Pot
can
life
raise
and
your
mixing ratio.
yes, pot life and mixing ratio. Why would you answer that? Can you explain what is pot life and what is mixing ratio, Sunil? Okay. Anybody else wants to try? Yes, Dr. Satish, you can go ahead.
Yes, for these type of polymer systems, uh, in case of any material of that kind, port life is very, very important because beyond a certain time limit, uh, it will not be very effective. Uh, it will not be used. So you have to keep control of the timing. And
Hmm.
mixing ratio is again very important. These are organic materials. Unless you mix in the specified proportions, you can.
Okay. I guess I was stuck. There is some issue on the internet on my side, I guess. Yeah, probably
Yes,
I
you are not.
missed some of. Yes, Dr. Satish, you were saying, you were
Yeah,
explaining what is pot life and mixing ratio. Sorry, I missed your
yeah, yeah.
statements due to
Yes.
some issue on the internet.
For chemical for any chemical of this kind, mixing ratio is very important. And then there is certain time limit within which you have to utilize the material, otherwise it will be wasted. So
Right,
port
right,
life and mixing ratio are the most important aspects.
right,
And since only two options are asked for, these two are the most important.
right. Thank you.
Others may be important, but the question asks for only two. So these
Right.
two are the most important.
Thank you. Thank you, Dr. Satish. Yes, so these two are answers. The correct answers are pot life and mixing ratio in case of polyurea coatings or polyurethane coatings or any kinds of epoxy coatings as well. What is pot life? I'll explain you. So, in case of these types of coatings, they don't come as a single compound. Rather, they come as two compounds. One is a part A and a part B, or the one is the uh, polymeric substance that will be applied as the coating, while the other one is a solvent or a accelerator that will allow for the setting of this both the compounds when mixed together. And these two compounds, the part A and part B, so the part A is generally a pigment or polymer, and the part B could be an accelerator or solvent. And these two parts are mixed together. So these two parts are mixed together, and the mixing ratio is the proportion of part A to part B. So this is very important because if we don't have an optimal mixing ratio of both these parts, then it will either not set or it will set very quickly. And then pot life is what? Pot life is the period between mixing of both parts till it remains workable. So these two, since there is an accelerated added to the pigments or polymers, then these compounds, when mixed together, they have a certain time period within which we have it remains workable, and we have to apply it as a coating on the concrete surface. If we miss that time period, if we miss the pot life of the compounds, then the polymer will be set as it is and will not be able to apply it, or even if we apply it by force, then it will debond from the concrete surface. So pot life and mixing ratio are very important properties of these polyurea coatings or any other polymeric coatings like epoxy. The mixing ratio has to be optimal so that we have the optimal amount of polymers as well as the optimal amount of accelerator or the solvent for proper application and setting of these coatings on the concrete surfaces. So the mixing ratio has to be optimal, and then the pot life has the pot life is the time period between the mixing of these two compounds till it remains workable, so that we'll be before it has set, so that we'll be able to apply it on the concrete surface. All right, so these two properties are very important for the proper application and effective application of these polymeric coatings on concrete surfaces. So these two are the answers. Moving on to question number 4. Typically, which among the following two waterproofing systems will help to provide a barrier and prevent the capillary rise of water from the ground to the concrete floor? The options given were horizontal water stops, drain boards behind the wall, weep holes, coarse sand layer below the floors. This is regarding waterproofing systems to prevent the capillary rise of water from the ground to the concrete floor. So this is a horizontal surface, the concrete floor, and we want to prevent the water from rising from the ground. Which of these two waterproofing systems would you choose in this case? Yes, can somebody answer? Yes, Dr. Satish, go ahead.
Since other people are not volunteering, I would like to reply. You see,
Yes.
we are talking about upward rise of moisture from ground to the upper structure. So
Right.
horizontal water stop is relevant.
Okay.
Deep holes, etc., drain wall, behind wall, these are pertaining to retaining walls. And normally we talk about horizontal movement.
Right.
Second and third are not relevant. Upward, we are talking about y direction, upward direction. So home are below the floor. In case of percent, reaction will not take place. So last option is also relevant.
Yeah. Your last line was not very clear. Can you repeat it again, Dr.
Uh,
Satish?
uh, in case of coarse sand, capillary action will be minimized, will
Right.
not
Right. Right.
exist or will be minimized. You
And
require very fine grained soil only for
right.
capillary action, clay,
Right.
etc. Here
Right.
it is a, so it will not permit capillary action. So it will be quite effective uh, in, in combating against the capillary rise.
Right. And regarding weep holes and drain boards, would you also answer like why would you not
Uh,
choose them?
these are these are relating to lateral movement. In case of retaining wall, you require weak hole.
Right,
So there is horizontal movement of moisture involved for
right,
releasing the pressure, basically. And
right,
drain board behind the wall. Yes, if in case we are talking about retaining wall, this could be one option, but here the intention of the question appears to be
right,
relating to upward movement of ground towards the construction.
right. Thank you, Dr.
One
Santosh. Very well explained. So yes, so horizontal water stops. So typically these are the components or tools to prevent the rise of water or the transport of water across two surfaces. And how they work. So typically, let's say this is a horizontal water stop. This is a horizontal water stop, and let's say this is a concrete element, and this is a slab on grade, actually, a concrete slab on grade. So there is ground beneath this concrete surface, and there is exposure to water table beneath the concrete surface. So the water can rise inside the concrete, and this is one layer of concrete, and beyond there is the concrete floor, right? And what we want is we do not want the water to go to this region. So the water can get inside. However, what if there is a horizontal water stop like this? Water stop. So the horizontal water stop, what they have is these rough corrugated surfaces on the um, on these water stops, and whenever the water has to pass through these, they extend the length of the path of the water. So typically the water has to now go through these corrugations and travel back upward, and then only it can go inside the concrete surface. So this will be the path of the water now. So they increase the path of the flow of the water, and therefore due to the increased path, the water will be prevented from flowing inside the concrete. So this is the horizontal water stops, and this will work efficiently, very efficiently, in the case of capillary rise of water from the soil into the concrete surfaces, because these are placed in a horizontal manner. So if let's say this is a wall footing, this is a wall footing, so I can just show it like that. Then these water stops will be running along this wall footings. These water stops will be running along these wall footings throughout the length, so that whenever there is contact with water, the path of the flow of the water will be increased, and therefore it will prevent water from entering into the top layer of the concrete. Therefore, these are very efficient tools to prevent the ingress of capillary water from the ground. Then what are drain boards behind walls? So typically when there is a water or a soil retaining wall, let's say this is a soil retaining wall, and there is a backfill. This is a backfill. So there is a chance that this backfill will be saturated, and there will be a hydrostatic pressure that will be acting on this wall. So this water from the backfill will try to ingress inside the concrete wall. So typically what they do is they place these drain boards behind the walls. These are the drain boards, and they have also these water collection centers inside their body, like the shape of a uh, egg container that we have, eggshell container that we generally typically have, a crate of egg. So these drain boards have such kind of a shape, and they collect the water from the backfill, and then typically there is a drain, a French drain or any kind of a drainage system beneath, which has holes on it, and the water collected in the drain boards over behind this wall will get accumulated in these drains and will flow out laterally without getting inside the concrete. So the concrete will not allow for the ingress of the water. Rather, the water from the backfill will be collected by the drain boards, and that will flow out through the French drains laterally without going inside the concrete. So these drain boards behind the wall, as it is suggested over here, it is typically used in case of walls or vertical elements which retain water or retain soil that has saturated condition. So this is not this drain boards will not work for the capillary rise of water from ground to the concrete floor. So this is not to be selected. Then what are weep holes? Weep holes are again so typically you might have also seen this in a highway um, or a flyover. So in case of flyovers which have reinforced earth elements on both the sides, reinforced RE tiles are given, and the subgrade of uh, the flyovers are filled with soil, and therefore whenever there is water getting accumulated in the highway. So I'll just show a cross section of this. Let's say this is the midrib of the highway, and this is the highway, and these are the reinforced walls. This is a typical cross section, and this is the subgrade. Highway surface with camber. So camber is a cross drainage slope. So whenever water is getting accumulated on this highway surface, it will flow down to the sides, and then there are these weep holes, the pipes coming out of the highway on both the sides. So these are the weep holes, and the water will flow out of these weep holes instead of getting accumulated on the road surface. So these are the weep holes, and they are typically used when there is a surface accumulation of water, like in the case of you might have seen on your roofs as well at your homes. There are weep holes that are protruding out of the base of the roof, so that whenever there is rain and there is water getting accumulated, there is a slight slope given towards these weep holes, so that the water will flow out of these weep holes instead of getting accumulated over the concrete surface. So these are known as weep holes. These are drain boards. And the final, so weep holes are also given when there is a surface accumulation of water, not a capillary rise of water from the beneath of the ground, and then therefore this will not also work in this case. Then there is coarse sand layer below the floors, and this is as Dr. Satish has already answered very rightly. So using coarse layer of sand or coarse layer of subgrade beneath the concrete floor will prevent the capillary rise of water. How? Because for capillary action to take place, the pore size has to be very small, the void size has to be very small, and this size of voids are present generally in the case of clay soil systems. So whenever there is a coarser particles are spread over the soil surface, then the void size will be very larger, and therefore capillary action cannot take place. Therefore, the rise of water due to capillary action will be prevented. So using a coarse sand layer, of course, this sand layer has to be properly compacted to prevent any differential settlement in the concrete floors. However, allowing for a coarse sand layer or providing a coarse sand layer below the floors will prevent the capillary action or capillary rise of the water to the concrete. So these two are the correct answers. All right. All right. Moving on to the fifth question. Which among the following can be given the least consideration while selecting a waterproofing membrane? And I guess this somebody had asked a doubt regarding this question in the last session as well. Okay, we'll discuss it again. Which the options given are, we have to give the least consideration to which of these properties, right? Surface finish before installation, elongation and tear resistance of the membranes, compatibility and bond of the membrane with the concrete substrate, compressive strength of the membrane, overlapping and gluing of the membranes. Which of these properties would you give the least consideration while selecting a waterproofing membrane? Can somebody answer? So, yes, Dr. Satish, go ahead.
I know therefore I try to reply to the question. Surface finish is important.
Right.
Elongation and tear resistance of the members, that is also very, very important. Compatibility and bond, very, very important. Compressive strength in case of skin is a thin skin. So that is not that important.
Okay.
So
We'll go
overlapping
with.
and gluing, that is again. So compressive strength is the answer. Overlapping is again very important.
Okay.
So the least consideration will be given to compressive strength.
Compressive strength of the membrane. Okay. Thank you. Thank you, Dr. Satish. Yes. So we'll go over these properties one by one. We'll discuss them one by one. First is the surface finish before installation. Now, this has to be given utmost care before applying any kind of waterproofing or any polymeric coating over concrete surfaces. The surface of the concrete has to be very clean, very well cleaned and free from any dirt or dust, so that it will allow for a good bonding between the waterproofing or the polymeric membrane and the concrete surface. So therefore, surface finish before installation of the waterproofing has to be given good consideration, has to be considered very well, and has to be done effectively in order to allow for a good allow for a sorry a good bonding. So this is very important. Then elongation and tear resistance of the membranes. Again, since waterproofing membranes are most majorly applied on exposed surfaces or on the outer surfaces which are exposed to sunlight and water, like from rain or in some cases snow. So these are exposed to the various environmental effects that can go on throughout the year, and also to the diurnal variations or the variations of temperature throughout the day and night. So therefore, these waterproofing membranes are subjected to thermal stresses as well expansive and contractive stresses, and therefore they should have a good elongation resistance, because due to the increase in temperature, the concrete surfaces will get heated up and they'll also tend to elongate. And since these waterproofing membranes are applied on the concrete surfaces, they will also be applied with stresses, thermal stresses, which will tend them to elongate. Therefore, these waterproofing membrane need to have a good elongation resistance as well as a good tear resistance, because due to the differential elongation between the concrete surfaces and the waterproofing membranes, they might be affected by tearing forces or shear forces, which might cause the tearing of these membranes. And once these membranes are torn, there will be cracks on these membranes, then water can get inside and the whole purpose of applying such a coating will be defeated. Therefore, they should have a good elongation and a tear resistance. to prevent breaking or cracking of membranes. These are very thin membrane coatings, typically several microns of coating, and therefore they are very much susceptible or prone to tearing due to these subjected when they are subjected to UV rays, then they get hardened and brittle and get torn, and therefore they should have a good tearing resistance. The third is compatibility and bond of the membrane with the concrete surface. Again, this is very important because since these coatings are applied on the concrete substrate, therefore they should have a good compatibility with the concrete. Compatibility in the terms of chemical as well as physical compatibility. First of all, that physical compatibility is the bonding between the membrane and the concrete surface. The concrete surface should be clean, properly cleaned and free from dirt while before application of these uh, membranes, so that they will have a good bonding. And second is the chemical compatibility, like there should not be any harmful chemicals that will be leaching out of the concrete due to the hydration reactions or any other reactions. So if these there are some chemicals or effervescence or uh, there is any efflorescence, like the salts are getting alkali salts are getting accumulated on the concrete surface, or there is seepage from within the concrete to the outer surfaces, so that they will affect the uh, purpose of applying these membranes. They will debond or delaminate the waterproofing membrane, and the whole purpose will again be defeated. So there should be a good compatibility between the concrete substrate as well as the waterproofing membrane that is going to be applied. Good compatibility as well as good bonding between these to allow for effective application and prevent delamination. And the fourth is compressive strength of the membrane. Since these are very thin elements, as Dr. Satish has also mentioned, these are very thin membranes of typically of several microns thickness, and therefore we do not want a good compressive strength of the membrane, because it is not the property that we're selecting this membrane to act for. These membranes are typically applied to prevent the water ingress from the outside to the inside of the concrete structures, and therefore it should be only doing that, and it should have a good bond and tear resistance, so that it will not get delaminated or peel off from the surface of the concrete. But we do not want a very high compressive strength of the membrane, and as this membrane will not be subjected to compressive loads. Therefore, this is the property that will be given least consideration while selecting the waterproofing membrane. And coming to the last statement, overlapping and gluing of membranes. Yes, this is also very important. And as you might have also seen in the lecture as well, whenever these coatings are applied on the concrete surface, they are applied in perpendicular what to say so they are applied in perpendicular polishes, or they are applied in two perpendicular directions, so that the voids between these membranes that are getting created during the application, they'll get filled, and there will be a good bonding between the subsequent layers of the application of the membrane, and they'll provide a good coating over the concrete surface, and restrict the water from getting inside. So there are several layers of coating is applied on the concrete surface in perpendicular directions, so that they fill the voids that is getting created within the waterproofing membrane. Also, there is a good bond between the interlayers as well as the concrete and the waterproofing membrane. So this property needs to be given due consideration while selecting the waterproofing membrane. So the answer is compressive strength of the membrane, right? Moving on to the sixth question. In an expansion joint in a building, the depth of the sealant applied is more than twice the joint width. Choose the relevant statement. Typically, the sealant would fail due to adhesive failure. Typically, the sealant would fail due to cohesive failure. Typically, the sealant would relax into a stretched shape and deform. Which of these statements is true for a situation in which the depth of the sealant is more than twice the joint width? Can somebody answer this question? Yes, Dr. Satish, go ahead.
That in case the sealant depth is less than twice the width, it will fail by cohesion. Now, in this case, the depth of the sealant applied is more than twice the joint width.
Right.
In the lecture, they told that failure will be due to adhesion.
Right.
So, so first option is correct.
Okay. Yes. Thank you. Thank you, Dr. Satish. Yes. So there are several types of failure that might occur when a sealant is applied in an expansion or a contraction joint. So let's say these are two concrete elements, right? And they have a sealant coating. And there is a backer rod provided, and this is a sealant coating. This is the backer rod. The backer rod is provided, and this is an expansion joint. The backer rod is generally provided to allow for the expansion joint movement of the expansion joint without providing a three-way adhesion between the sealant and the concrete surface. So typically when there is a backer rod and the sealant, this is the surface of the sealant. And when there is a backer rod, the sealant is in contact with the concrete surface only on these two locations and not on the third location, third site. Therefore, this backer rod will also not have a very good bond between the sealant and the backer rod, because that will allow for the expansion of the joints and the movement of the concrete further apart or closer towards each other. Now, typically when these sealants are applied between two concrete surfaces, there can be several modes of failure of these sealants sometimes if they are not properly applied. One is adhesive failure. Now, if this is the concrete surface and the sealant is like this, and the depth of the depth is larger. So I'll mention the depth at H is larger than D by 2, and this is the diameter of the backer rod, or D. If this depth is greater than D by 2, then this sealant surface will tear off from the concrete, will sag, it will tend to sag, and the sealant will tear up from the concrete surface, and this will lead to an adhesion failure. So this is an adhesion failure, which is the case in this question. But when this depth is too short, generally the depth of the sealant is kept as half the diameter of the backer rod. But if the depth is too short, let's say in another case, I'll draw another figure. This is the sealant surface, and the depth is too short. So the H is less than d by 2. Then what will happen is there will be breakage between the sealant. The sealant will have a cohesive failure because it will not have a sufficient thickness of the sealant and will not be present at these locations, and due to the movement of the concrete, due to the expansion and the contraction movements, this sealant will experience stresses and it will tend to break. So it will show cracks like this. There will be breakage of the sealant, and this is a cohesive failure. So between the sealant itself, it will fail due to the unavailability of sufficient thickness of the sealant at this region. And then there is stretched shape and deformation caused due to the sealant relaxation. So sometimes again due to the contraction or the tensile forces, the expansive tensile forces or the compressive forces, so this sealant will get extended and it will reach a stretched shape. So this is the relaxation form, deformation, deformation and stretching due to stresses. This is typically due to long-term application of these expansive stresses or moving away of the concrete surfaces from each other, and this might occur. This might result in the stretched shape of the sealant. But in this case, what is mentioned is the adhesion failure because the depth of the application of the sealant is more than twice the diameter of the backer rod or twice the joint width, and therefore this will uh, uh, create a situation where the sealant will peel off from the concrete surface and there will be an adhesion failure. There will be debonding of the sealant from the concrete surfaces on both the sides. So this is a case of adhesion failure, right? Moving on to the seventh question. What are the three key properties to be considered while selecting a sealant system for a rooftop? And these are some of the given properties of the sealants, and you have to choose three major properties of the sealant for a rooftop: puncture resistance, high stiffness, high thermal conductivity, UV and chemical resistance, or abrasion resistance. Which three key properties would you choose for a sealant which is to be applied on a rooftop? Can somebody answer to this question? Yes, Dr. Satish, go ahead.
Please, brother, I don't want to indicate, I will attempt to answer.
Yeah.
In case of system for the rooftop, puncture resistance is very, very important. Then it is exposed to ultraviolet rays, etc. Chemical resistance is also very, very important.
Okay.
This abrasion also comes in picture because some items may be dragged, that abrasion resistance may be required.
Okay.
Other properties are not that important. If we talk of priority among these properties,
Mhm.
then these three are the most relevant.
Okay. Okay. Thank you. Thank you, Dr. Satish. Yes. So let's discuss all these properties one by one. One is puncture resistance. So what is puncture of the sealant system? Whenever there is a coating or a sealant that is applied in a gap or a coating is applied over a concrete surface, typically due to application of a concentrated load at a certain region on the coating, uh, these these coatings might break at that region particularly by puncture or punching, what is known as punching, and therefore these since this sealant system is a will be applied on a rooftop, so since the rooftop will be exposed to a lot of different types of environmental effects like rain or snow or different temperature variations as well, or sometimes there might be movement of heavy objects over the rooftop, and therefore This sealant system need to have a good puncture resistance. The puncture resistance will prevent the breaking or tearing of the coatings or the sealant system at a particular location by punching failure. So this is very much required. Then the second property is high stiffness. As a sealant system will be applied to bridge the gap between two concrete surfaces, and therefore the sealant should be flexible enough to allow for the movement of the concrete surfaces apart from each other by due to expansive stresses or due to thermal stresses during the temperature variation, and therefore the sealant should not be stiff enough. It is very If it is very stiff, then when the concrete surfaces tend to expand or contract due to the temperature variation, then the sealant will tend to break because it will experience a lot of stress, and since it has very high stiffness, it will not move along, and rather it will restrict the movement, and therefore it will crack. So a high stiffness of the sealant is not required. High thermal conductivity, in fact, since this is applied on a rooftop, so it will be exposed to sunlight, and therefore the sealant system should be such that it should also prevent the increase in the temperature of the inside of the building. So therefore it should not allow for thermal conductivity. It should not allow for the thermal stresses or the heat from outside to get inside the building, so as to keep the building cool on its own. So a high thermal conductivity is not required in a sealant system, rather a high resistivity, thermal resistivity is required, so that it will not allow for the temperature change inside the building caused due to the temperature change outside the building. Then comes the UV and chemical resistance. Yes, the sealant system needs to have a good UV and chemical resistance. UV resistance needs to be there because it will be exposed to sunlight, and the sunlight will have UV rays. And when these UV rays hit on these polymeric coatings, these polymeric coatings become brittle in nature, and they tend to break and tear off or peel off from the concrete surfaces, and therefore this is also similar in the case of sealant systems. Therefore they need to have a good UV resistance. Again, chemical resistance is required because it will be exposed to rain as well, since it will be on the rooftop, and some with recently there is increasing case of acid rain. So this the rain when the first rain comes in the rainy season, then this rain comes with a lot of chemicals or lot of hazardous substances that are being carried in the air, and therefore they come as concentrated forms of chemicals, and they might affect the sealant system. Therefore this sealant system needs to have a good chemical resistance as well. And the last one is abrasion resistance. Again, since this is going to be on a rooftop surface, and there might be possible movement of any heavy objects on the roof, or this roof might be exposed to hailstorm or snowfall as well with the due course of time, and therefore the sealant system needs to have a good abrasion resistance so that it will not be abraded or uh, torn off by the application of impact loads due to hailstorm or anything else. So the surface of the coating needs to be intact even when a hard surface gets rubbed against the surface of these coatings. Therefore, the sealant system needs to have a good abrasion resistance as well. So these three properties are very much required: puncture resistance, UV and chemical resistance, as well as abrasion resistance. Right? These three are the correct answer. Moving on to the last question. Choose the correct statements regarding the brick-bat Koba system. And these are some of the statements written over here. A properly designed and constructed system will give insulation to both water and heat. The systems are flexible and prevent the formation of cracks due to temperature variation. Water can seep through the cracks, if any, on the system and can lead to corrosion of the RC slab below. Which of these statements are true? regarding the brick-bat-cover system. Yes, Dr. Satish, go ahead.
Uh, you know, brick bats are involved, so it will provide insulation value to the roof, and it can absorb lot of moisture also up to 20% or so. So it is a good insulator against heat also. So first one is correct.
Okay.
Then it's not a flexible system; it's a rigid system. Second
Okay.
option is not correct. Then water can seep through the cracks. Yes, cracks can take place, and water may go in, and this water may act as a sink, and it may corrode the RC slab down below. So third
Right.
option is also correct.
Right. Thank you. Thank you, Dr. Satish. Yes, so as the name suggests, big bat cover systems contain these brick bats, which are provided as a layer over the RC slabs. And the typical use of these brick bat cover system is to uh, provide insulation against water as well as heat. And since these are fired clay bricks, so therefore they are actually good insulators of heat, and they provide a good resistance against the temperature variation. So they provide a good uh, protection against the rise in temperature due to the uh, outside environment. So providing a brick bat coba, if it is properly designed and constructed, then it will provide a good insulation against both water and heat. So this is a true statement. However, since this brick bat cover system contains bricks which are brittle material, therefore these are not flexible systems, rather these are rigid systems. And when so typically if this is a concrete slab and there are these brick bats provided on the surface of the concrete slab, and they are bonded using certain mortar, the mortar layer. Since the brick bats are rigid in nature, therefore when there is temperature variation and there is rise in the temperature, and the concrete slab tends to expand, so the brick bats will not allow for the expansion, and therefore this will lead to cracking in between layers of mortar between the brick bats. So there will be cracking. These are the cracks. The cracks will be formed between the brick layers, and when these cracks are formed, once there is rain, water can get inside these cracks. And since these are bricks, so bricks have a good water retention. They can absorb a lot of water, as Dr. Satish has also mentioned. They can also absorb and retain a lot of water, and they will act as a water sink. And this retained water can get and sip inside the concrete surface beneath the brick bat coba layer, and they can affect the steel reinforcement in the slab. So therefore, water can seep through the cracks and corrode the reinforcement. So therefore, these are not flexible systems, and rather they allow for the formation of the cracks, or they accelerate the formation of the cracks as they are rigid. So they don't move along with the temperature variation, and therefore they can allow for the creation of these cracks, and these cracks can allow for collection of the water inside the bricks, which can further accelerate the corrosion process in the RC structure below. So the last one is a correct statement as well, right? Right, this ends the assignment questions. If you have any doubts regarding the week's lectures or any other previous week's lectures, then we can take those doubts now. Yes. Otherwise, the session will go on till 8 p.m. If you have any doubts, you can raise your hand and ask those doubts. Otherwise, you are free to leave.
Well presented, Mr. Ashwin.
Thank you. Thank you, Doctor. All right, I'm muting myself. If you have any doubts, then please raise your hands. I'll attend to your doubts. Okay, we are closing the session for today. We'll meet again on the next Saturday from 6 to 8 p.m. Thank you.